Chris from out of FabLab at the moment, home actually at the moment, but doesn't matter. Today I am going to try to tell you so what is the how to use and how to update the Fab KiCAD library, and so that you understand better what it is. I'm going to share the screen. So here in the browser we have it open. So if you go to FabCloud, gitlab.fabcloud.org, and you go to Pub and Libraries and KiCAD, you will see this. And I separated it from the initial electronics libraries repository because there is a lot of things to do with it. All the components, they had to be updated, and a lot of components had to be added still. So here you can see a list of what has been done and what is still missing. So some of the microcontrollers are already there. I just have to finish up by adding more. And so the purpose of this library is to mirror the inventory, the Fab inventory that that you can see in this Excel sheet. So I'm kind of looking into ways how to make it easier to understand and easier to map with this repository. That's another discussion out of the scope of this video. But mainly it should make it easier to collaborate between different systems. So let's say that you or your student has a design in KiCAD, and he or she wants to share the design, and you want to update it. It's going to make it easier to do so. Because what I discovered with KiCAD is that when you download the official libraries, on each of these systems, the libraries are different. And if you're building something on Mac, then it's not going to be the same on Windows. So when you're going to open the project on Windows, then you will need to replace all the symbols, or maybe not all, most of the symbols and most of the footprint libraries, so that you can actually do something with the design. And in order to avoid that, it's good to have the same. It's good to have the same library in all systems, and in this case, it's going to be the Fab library. In order to use it, you have to clone or download this repository. So let's go through the process right away. So as you probably, as a Fab instructor, you want to be able to update the library, but if not, it's okay. And in order to, so this is why you should choose the git at GitLab URL. So you copy that, and then you go to your terminal, and here I made a directory for the demo, and make a directory libraries, and go into the libraries directory and git clone the address. Okay, it's there. And if we go in, I can make this full screen. See, we'll see this list of files, and so the main, the most important is the fab.lib file. So this is where the schematic symbols live, and then there's a directory which contains all the footprints, and yeah, license readme. Then DCM file is important because it contains all the descriptions and metadata for each of the elements that are in the lib, in the schematics library. And then test.py is the script that is there to be used in order to test these. We're going to cover that later. Now let's switch over to KiCAD itself. So here we have the project manager. So, and first things first, we need to add the library here to the library manager. And I'm going to add new existing library. Yeah, so here we go. So demo libraries KiCAD. This one, fab.lib. Okay, here we go. So I can hit OK, and then I'm going to go to Preferences and Manage Footprint Libraries, and I'm going to do the same here as well. And I'm going to add the Fab Pretty directory of this one, and hit OK. So once that is done, we should create a new project. And I'm going to put it in the demo directory and call it Fab Library Test. No, Fab Library Demo, as it is a demo after all. And we usually start with a schematic. And let's say that we are building something for 80 tiny 1614. So in order to find the symbols in Fab Library, you can find them by typing Fab, the actual component that you are looking for. So we are looking for 80 tiny 1614. And maybe if you have been using the Fab library in the past, you noticed that it's not very easy to look for things in this with the help of this search bar. And that was because there were no metadata entries in the description file. So the thing that I'm going to cover later. So it's important that for each of the library component, that for each of the library symbol, there is an actual metadata entry, so that this part actually becomes usable. Let's click on this here, and let's just add a few things, like for example, resistor, this trimmer. So just a few random things, really, just to test how it works, and we can even add a wire here and a wire somewhere else. So it really doesn't matter at this point. Yeah, you get the idea. So I can cover, how to design the things around in other videos. I will actually share a few links where I do that a bit later. Then the usual flow is that you annotate like this, and that you use the assignment interface in order to assign footprints. Here we go. So as you see, we have two components over here. So one is the potentiometer and the other one is microcontroller. And the Fab library is built in a way that each of the symbols actually has a footprint. And there's so a footprint mapping. So if you use the built-in symbols, then sometimes it is that this part is empty, so there's no specific assignment. Since we know what kind of parts we are using during the Fab Academy and to build all the machines and all of that, so the task of actually assigning footprints is easier. So each of the components actually has the footprint map. But then if you, for some reason, want to use a different footprint for a resistor, let's say, then you can always go and change it. So let's maybe look at this scenario. So let's add a generic resistor, Fab R over here. Oh no. And let's connect it to a wire. So, and then add a no connect at the end. And then annotate, and then go back to the footprint assignment over here. So you see there's a resistor 1, and it's assigned to resistor 1206 footprint. But then how about we want to change it to a smaller one, like let's say 0804. That's possible. So yeah, that's possible. So you can go to the resistor SMD part, and here, yeah, there's resistor SMD R0805 or 20 12, so this is 2 millimeters by 1.2 millimeters metric, and you can assign it very easily. But in this case, we actually would like to stick to the default one. So this is why we're going to hit cancel. And the next step is to create a netlist. Create netlist in the same folder where you have the project. And after creating the netlist, you can switch over to PCB new, which is the which is the PCB editor. Here I have it on the other screen like this. And I should click on this one in order to load the netlist. And this is the netlist, and then I can update PCB, close this, and put it in a place where I like. And as you see, so here are all the footprints, and you can move them around like so. And then you can do the tracing and all the tests and exporting and so on. That's that. I will maybe save this for now. Also save this. So yeah, the next thing is that we would like to add some missing footprints and symbols to the library. So how do we do that? So also just recently there were a few new things that were added to the library. Let's look at the microcontrollers section over here. So yeah, there are still the old ones, 44 and like 80 tiny 44 and 45s, so these are not important anymore. So last year we added the 412 and so the 01 series, and this year, and yeah, we also added the SAMD ones, but this year I noticed that there's this part which is a new microcontroller that is not yet in the library. So how can we tell that it's not in the library? We can open up KiCAD again. Here we go. And there's the symbol editor. Let's click on that. And we can type Fab. And with the existing ones that were there in the Fab library, I made it so that the symbols, the microcontrollers, have a microcontroller prefix in front of them. So according to the KiCAD library conventions, so for each of these things, there should be a separate library as a category, but since the Fab library has a limited size, so there's a limited number of components. For now, I decided to keep it in one library and just add a prefix instead of another library file. Maybe it's going to change in the future. So, but we see that if we look for microcontrollers, we have only these 5, and there is obviously nothing that looks like this. So in order to add this to our library, we need to go to Digikey and look it up. So here I have it in the tab already. And you can see some default specs of it already. So there's a short description, long description, yeah, the manufacturer, part number, so which is probably the most important part. And then there's also a link to the data sheet and so on. Yeah, if you open the data sheet, so here's also the 32-pin TQFP pinout. So if you look closely to the actual description and the name, you will see that it's 32-pin TQFP package. And yeah, so this pretty much maps to this. So where the white dot is, this is where the pin number 1 is, and it has all these names and descriptions. So how do we make an actual KiCAD symbol out of this? So let's go back to KiCAD symbol editor, and the best way to start is to look for something that is similar. So let's see this 80 mega 3260 AU. wondering if the pin count over here, no, so this is TQFP44. We are looking for something that is a TQFP. This is much better. So it already, so it's kind of assigned to something that has, that uses the TQ, that is mapped to the TQFP32 package, 32 pin package. So you can actually take this symbol and reuse it for its purpose, because it's already designed taking into account the KiCAD library conventions. And we can just go and save as, select the Fab library. Oh, where do we have it? Oh, let's see, Fab. Yeah, here we go, Fab. And let's name it to include the manufacturer number. So I'm going to click copy here. And as I said before, in the library, in front of microcontrollers, I add the prefix microcontroller, and then an underscore, and then this. So what is a bit confusing is this PT, so, and this, not this PT, but this slash. I'm not sure whether it's actually going to be converted into something good. So I'd rather use this one, although maybe let's try. So maybe it's not that bad. So I'm going to click on save. So, and as you see, it's there. Here in the Fab library, now we have AVR 128 DB series. Yeah, so we have the entry in the Fab library already. So what do? We need to, maybe let's take this so a bit aside, and can we hide the tree? Yeah, we can hide that. And let's open up this reference, so this data sheet, and try to rename the pins so that they actually reflect what we can see here. So it's going to be a longer process, so I'm going to probably speed it up in editing, but yeah, let's go. So let's start with pin 1, which is going to be this one. Let's move it somewhere. Then pin 2. Yeah, one important thing before we really dive into details is that you should set the grid to 2.54 millimeters. So because this is going to make it compatible with the schematics editor later. So sometimes, so when I just started adding symbols to the library, I did a mistake and I didn't really care about the grid here. And I produced a few symbols that that when I run the KiCAD library convention scripts, they show that it's wrong, and they're causing problems in terms of connecting them to existing symbols in your schematic. So make sure that this grid is set to 2.54 over here when editing the symbol. Okay, so pin 1, so we can move it around. So I press M to move it around, and press R in order to rotate it. And then I hit E in order to open the editor. And pin number 1 in the datasheet is PA3. So everything else I'm going to leave the same. So one thing that you should take into account is that you should pay attention to is the electrical type, and for GPIO pins it's usually bidirectional, because like internally in the chip you can define sometimes what it is. But basically it's bidirectional. So you can read things with it, and you can also write things with it. So you can measure a digital sensor, so whether a button is pressed, and you can also blink an LED. And here we see that we'll need to change the electrical type to bidirectional, because it is actually a GPIO pin. It's going to be PA5. We don't want it to be grayed out, so I'm not gonna, yeah, so it's bidirectional, PA7. It is visible. Okay, here we go. Number 6 is going to be PC0. And at this point, so since I have done this one time already, so I know that the layout of these is going to be such as that I'm going to leave the PA ports on the left side, and the rest of the ports I'm going to put on the right side. So I'm just going to make some groups of ports over here. Number 10 is VDD-IO2, which is positive voltage, and according to the KiCAD conventions, usually the voltage pins should be on the top, and then the ground pins, they should be on the bottom. So this is like a rule of thumb to keep in mind when designing your schematics as well. And here, instead of bidirectional, we'll need to specify it as a power input, because it basically is power input. So it's VDD IO2. So as far as you could tell, it's voltage supply for the input output, probably bus 2 or something. And let's hit OK. From C, then there's D, and after D, there's F, if I remember the alphabet right. Yeah, and that's about it. Now we can save this. Another thing to look at is the Properties tab over here. Usually there are designators for every type of component that you add, and in order to be sure what that reference here has to be, you should go to the KiCAD Library convention. So do not worry if, so yeah, it's like libraries KLC. So you also have the link to it here in the library. So when you go here, there's the link. if you go here, and where was it? It's a reference. Yeah, so here, symbol metadata. So also, like when you are designing new symbols, it makes sense to open this document and go through it at least once. And here you can see, so what kind of designator you need to add for specific parts. So there are so many different electronic parts. Most of them, they are not in the Fab inventory, and we are not using it during the course, But here you can see that U generally stands for integrated circuit, and microcontroller is generally an integrated circuit, so that here the letter U is actually right. Here, this is the value, which actually should be the name of the chip. So let's take this. Then the footprint, yeah, so here, since we copied this, so we started out with a different symbol, with an existing symbol. This is a footprint that it was mapped to, and here you see the semicolon over here. So the semicolon separates the library where it is stored from the actual footprint, and this name of the footprint, it's actually built by taking into account the KiCAD library convention. So it starts out with the package name, which is TQFP 32 pin. Then there's the X and Y dimensions in millimeters. So you specify 7 Y by 7 and then the units. And then usually you can give it additional parameters to tell them apart much easier. And in this case, there's the pitch keyword, and the pitch in between the pins, it's 0.8 millimeters. And what we are going to do, we are going to replace this with Fab. So since we are going to use the footprints from the Fab library. And we would like also to add the link to the data sheet. So what I'm going to do, so when I click on this, this opens, I can copy this link over here and go back to the symbol editor and select this, delete it, and paste the new value in. So here we have the symbol name, there's the description, and the description, I really like how Digikey is managing it, so I will just copy it from Digikey, and instead of the short description, I could just copy the short description. And keywords, I don't think whether it's Mega AVR, I think it's the DB series, and I'm gonna add still that it's TQFP32. And it's interesting that in Digikey they flip these numbers around, and somehow in most other cases the TQFP32 or so these packages are in KiCAD libraries that usually are named in a way that the number comes after the actual designator. Yeah, there are some other properties that are not important at this point. So what you should take a look at is usually the aliases, especially if you are copying it from another symbol, because like there are sometimes the aliases which we do not need. And then the footprint filters, this is a good thing. So if you want the footprint to, if you have more footprints that could map to this symbol, then so here you can kind of enter a regular expression and pattern, so that KiCAD has a easier time finding the relevant footprints. when you are mapping them. But all in all, this seems fine, and I can hit OK. So I have to save it. We'll see that there are two files that have been changed. So the one is fab lib, the other is fab.dcm. And if we type git diff, it's going to show what exactly has been added and changed. So we can see that in the file fab.dcm, so these fields, these lines have been added. So you see like a new component definition, which is AVR128DB32. Then there's a description, there are keywords, and F stands for datasheet entry, and then there's end component and a symbol that kind of separates the symbol entries. And then in the lib file, we have the actual component entry. So there's a name, then there's the definition of it. So which also shows up in the editor. So there are like some things so there's so what kind of designator it should have. I think this is a location where it should be. Some other things. Yeah, this is the footprint, for example, that maps to. And this is the filter that is used by KiCAD in order to be able to find the necessary footprint. And then these are all drawing commands. So you can see also like the pin labels are described here, and they have certain locations over there. And then before you add them to the Git repository, it is recommended that you run the test.py. So make sure that Python 3 is installed. So you can use Python 3 and then run the test.py. So you see there are a lot of errors because I recently added a part which checks whether there is a description or metadata entry for each of the existing parts. And there's some parts from the older version of the library that are still there that I haven't really checked and updated yet. So they are not so easy to find in the editor. But what we are looking for is this missing footprint. And we see that there is no TQFP32 footprint entry in the fab.pretty directory. So if we go fill list as a list, if we list the footprint library, which is Fab Pretty, then we see that these are all the existing footprints, and we should create an entry for the footprint that we are working with. So let's go back to KiCAD. So now we're back to the project view, and in order to add the footprint, we can open up the footprint editor. So it probably makes sense to disable all the footprint libraries that you are not using, but then while you're building the footprint library for the Fab Academy, it makes sense to have the existing footprint somewhere available. All right, now we are in the footprint library, and we are going to look for TQFP32. And so if we go back to the data sheet over here, so we'll see that it's 7x7, 32 TQFP. So these are our guiding parameters. Maybe even like the pitch should be visible somewhere here. Alright, so, but this is what we need. So TQFP 32 7x7 millimeters with 0.8 millimeter pitch. So we open this up, and the first thing that we do, we save it as the same name, but in the Fab library. One thing that is important to check is the spacing in between the pads. Because we are milling with the limited size of tools, so usually it's 0.4 millimeters, but we at the lab have the smallest tool that we have is 0.3. So for these high resolution, so with these smaller pitch components, we are using the 0.3. So it's important to make sure that the distance in between the pads is 0.3. So how do we do that? So I'm setting the grade to something smaller, so in this case 0.025, and I'm using this measure distance tool in order to zoom in, click here and then here, and as we see the distance between those is 0.25 millimeters, which is a bit smaller than we need. In order to change that, you can hit E while hovering a pad and then change their parameters. So I'm gonna change this size Y to 2.5 and hit enter. And now I'm gonna do the same for each of the pads. So it's gonna take some time. So I'm gonna speed this up. Okay, so now we've done changing all the sizes of the pads. Now, just for the final touch, I would like to add one circle over here, just to make it easier to understand where the first pin is. So I'm gonna take this circle tool and just draw a small circle over here. So yeah, and where did it go? So another good thing about reusing existing footprints is that it has all the things you need. So it's nice to have all of these because like not all of these things are necessary for PCB milling. So for example, this silk screen layer, this blue one, it's not needed, and actually in most cases it's better to actually get rid of it and hide it inside the actual footprint somewhere. But then if you decide to move to a more sophisticated production technology and you want to send your design to a manufacturer, then it is important to have all these additional layers. So for example, the courtyard layer, it is specifying the actual amount of space the component is gonna occupy, so including all the pins and the soldering and yeah, the components. So how much space is gonna occupy on the board. And then the silk screen, of course, it is important to have it like in order to identify where the components actually have to be placed. And what are the values of the components. Then the footprint indicator is nice to have. So all of these things, they are quite important. And then if you reuse existing footprints and add them to the Fab library, then these things are already there and they are compatible with the KiCAD official library convention, and you don't run into trouble later. So now when we have this, we can save it. And so before we add it to the library, we could do another like manual test. So now when we have this Fab library test project over here, so what we can do is, so we just double check that we have all the, yeah, we can delete this. So let's say we want to replace this microcontroller with the one that we just created. So we can hit A to add, and then Fab, AVR. So this is the one we want. Here we go. Yep. It also connects nicely with the previous design, which is nice. So save it. And I'm going to go to annotation and annotate it. Then I'm gonna go to the mapping tool, and it's showing me, yeah, so the correct mapping. And if you're still not sure, then you can always click on View Footprint. And also here you can use the measurement tool in order to measure the distance between the pads. And it's 0.3, exactly as we wanted. You can close this, and now we can export netlist, generate netlist in the same directory. And we can switch over to the PCB design. And since we have the previous entries over here, so we just need to update the netlist. Update this, close. You see, it doesn't delete the older ones, the previous one, the previous footprints, so you need to make sure that you do that yourself. And here you go. Yeah, so I'm just gonna save this, close this for now, and go back to the Git repository and git add fab.lib, add fab.dcm, and fab.pretty tqfp32. So we are adding 3 files or 3 changes. So what are we adding over here? So let's go a little bit up. No, let's go to the website. Just want to copy the manufacturer number. That's it, we have a commit, and we can push. Ta-da, now it's up. You can go back to the library over here. So I'll refresh. And what we see is that the latest commit is there and the pipeline is running. So you can check what's going on with the pipeline. So as you can see, there are all the errors that we saw previously when you run the script locally, but it's all right. So thanks for watching. This is a really quick introduction into how it is possible to use and update the Fab KiCAD library. And hopefully it's going to get better over the semester. So I'm going to continue with adding the missing footprints, and at the end of this cycle it's going to be so good.